All right, guys. Hey, welcome back. This is Piecewise Functions Part 3, okay? Our last part. The previous lesson we talked about was step functions, and we seen what that looks like. And we also talked about how an absolute value function is really a piecewise function too, almost like a disguise. So today what we're going to do is we're going to come up with evaluating, okay? Evaluating a piecewise function. So what would f of -4, f of 6, f of -2, if I plug these numbers into this function, what's my output? Okay, so that's the goal for today. I have 3 examples to go through, all right, just to kind of get a good variety here. So here's what you're going to do, okay, to evaluate these guys. Look at the very first problem. It says, hey, plug -4 into this function and tell me what the output is. Now remember, with piecewise, we have these restrictions. These restrictions tell me what part of the function I'm looking at. And we've seen that visually in the first lesson. So if I plug -4 in, where is -4 allowed to be plugged into here? Well, if I take a look, -4 is less than -2. So I'm allowed to plug it into the first guy right up here. So this is going to be 2, well, I'll tell you what, let me write the full thing. It's 2x plus 8. That is the guy I'm looking at because -4 is allowed to be plugged into here. So that's 2 times -4 plus 8 that I have, which is -8 plus 8, which becomes 0. So f of -4 is 0 for that guy. Okay? Try another one. 6. Where am I allowed to plug 6 into? Well, I think this guy. X values that are bigger than 3, use this function. Okay, so square root of x plus 3 is what I'm going to use. We'll plug 6 into it. Okay, so that's the square root of 6 plus 3. Square root of 9, which gives me 3 for that guy. All right, one more to go. -2. Where am I allowed to plug -2? Well, got to be careful. Okay, this is where the inequality symbol is very important. -2 is seen in 2 of these, right? But -2 is allowed to be part of this guy's domain, not this one. So I got to look at the top one. So it's going to be 2x plus 8. That's the part of the function I'm allowed to plug -2 into. So once again, that's 2 times -2 plus 8. -4 plus 8 is what I get after I simplify. And then we come, what, 4? Come to a result of 4 for that guy. Okay? So the process behind this, it's figure out what your x value is, pick the right function in this piecewise that you're allowed to plug it into, which means you're going to have to look at these, okay, the restrictions of it. Make sense? Okay. So let's try another. Goodbye. Hello. There's example 2. Okay, and I'm trying to make the video as small as possible, so pause the video so you can write down the example. I'm going to go ahead and start. So f of 8, when I plug 8 into the function, what's my output? Okay, so 8, where am I allowed to plug it into? Not the top guy, because it has to be less than 1. 1 and 5 is this. Here, if x's are bigger than 5, I can plug it into this. That's what I want. So I'm going to plug it into this function right here, that part of it. So that's going to be 8 minus 2, which would give me 6. And the absolute value of 6 is 6. So there I go as my final answer. Okay, let's keep going. 0. Which one of these functions is allowed to have 0 in it? Well, not the top one. It has to be less than 1. Okay. Well, actually, no, I think it is the top one. I misspoke. I'm sorry. Because this guy's between 1 and 5, and this has to be bigger than 5. So it is the top one. So it would be 2x cubed minus 1. That's the function I'm allowed to use, that part of it. So 2 times 0 cubed minus 1. And then this is gone, right? So it's just -1. So -1's my output. Next up, 4. Where am I allowed to plug 4 into? Well, I think it's this middle guy, right? Now notice, this is a horizontal line, right? That goes through 3 on the y-axis. So no matter what I plug into, between 1 and 5, no matter what I tell it to, the answer is always going to be 3. So there we go. That one's done. No, nothing to really compute there. And then for the final one, 5, okay, where am I allowed to put 5 into? Now, I did make an error. I apologize. I just looked at my paper now. That should not be an equal to sign. You could scream at me. You could say, what are you doing? I apologize. I wrote that down incorrectly. So 5 is not allowed in this guy because it doesn't include 5, right? Now since I erased the line. But 5 is allowed to be in this guy. So I'm going to use the absolute value of x minus 2. Okay, so I'm going to go ahead and substitute 5 for that one. And I get 3. And if you take the absolute value of 3, you still get 3. Okay? Can you look at this on a graph and get those answers? Absolutely. Look where x is 5 on that graph, and then go up or down and see where the graph is at that point, and look at the y value. So just like previous graphing experiences in Algebra 1, you can use the graph to find the output. This is just algebraically. Okay, find the x value that works with one of these, then go to the function, plug it in. Okay, I got one more. One more example. Goodbye. So long. Farewell. Sound of music. I'm not going to sing it. Nope, you're not going to catch me singing that. Okay, so here's the final example. And this time I got 4 functions to deal with. Okay, and I'll tell you what, let me just scooch this up a little bit so you can see that. All right, so first one, we got to find what 5 is, f of 5. So where am I going to plug 5 into? I think this bottom one, right? You see that? X's that are bigger than or equal to 3, use this one. So 1/3 x plus 8. So it's going to be 1/3 times 5 plus 8. So does that be 5/3? Finish it. And then 29 over 3 when you add those two together. Okay. I encourage you, pause the video. I haven't been given time to work on this because you have that ability to pause. So let's look at this guy. If I plug 1 in, where's it going to go? Well, I see 2 functions that talk about it. It's the middle ones, right? See how they both talk about that? But this one does not include 1. This one does, right? There's that equal to sign. So it's 1 plus x squared. That's the part of the function I'm going to use. So that's 1 plus 1 squared, which becomes what? 2? As a final answer. Hopefully you're kind of getting the gist of it. It's, like I said, it's like a location thing, okay? Here's my x value. Which one of them can I use, okay? Whenever I find that one, plug the number in, do your algebra, and figure out what your output's going to be. All right, last one, -4. Where can I plug -4 into? Well, there's 2 options that talk about it, this one and this one. But which one is allowed to use -4? That's the top one, because there's an equal to sign there. So 2x plus 7, and the absolute value, that's the guy that I'm going to plug it into. So that's 2 times -4 plus 7. Okay, when I multiply that, I get -8 plus 7, which becomes -1, and the absolute value of -1 just becomes 1. Okay, and that's it. That's evaluating. Once again, could you look at the graph and get the same answer? Absolutely. Okay, locate -4 on the graph. Go, up or down depending on where it's being graphed at, and locate the y value that's associated with it. Okay, so we'll get some practice on this. I'll throw some graphs your way, and you can actually see how the algebra matches with what you see on the graph, so you can make that comparison. Okay, other than that, that's it, guys. So that's evaluating piecewise functions. Let me know if you have any questions. And until next time, I'll see you in the next video. Have a good day.